For question number 3, page 158, I've set this up. We have the given, we have the proof. We know we need to prove that yx is congruent to zx, so I'm going to put this down here. I'll give myself lots of room. So we need to show yx is congruent to zx. And I would like to do this by CP/CTC. I'm noticing that yx and zx are not in a single triangle. So if I'm going to use CP/CTC, I need to have triangles. And what I'm going to do is construct some triangles by connecting point O and point X. So that's going to be just draw a segment OX, and of course the reason, 2 points determine a line, or through any 2 points. Through any 2 points, there exists a little backward Z, that's a little shortcut for there exists exactly one line. So now I have 2 triangles, and in fact, I know that I have perpendicular lines, so I know that I'm going to have right angles. So I'm going to say angle Y and angle Z are right angles, definition of perpendicular, obviously. And as long as I have right angles, I know I can use HL theorem. And it turns out that, in fact, I do have 2 right triangles, right, because I have right angles. And I also know, so I've used that. I also know I have a circle. So obviously, all radii are congruent. So I'm going to go right to that. I'll have OI congruent to Oz. And that is definition of circle. Or you could write all radii in a circle are congruent. I'm also going to say ox is congruent to ox, reflexive, and I have met all the conditions for using HL. I've said I have a right angle, and OX and OX, they're the hypotenuse of each of these right triangles. I have a leg, OY and OZ, so I can say triangle OYX is congruent to triangle OZX, and that is by the HL theorem. So then, by CP/CTC, these 2 segments are congruent.